Hello, my name is Bob, and once again I'd like to welcome you to another episode on the White Dog Garage YouTube channel. Having bought the MIG welder, I need to position it so that I can use it along with my other welders, and it makes sense to position it with the TIG machine so that they can share the one gas bottle. So this is my existing welder trolley. I could put another level on it and stack it. The thing with the MIG is you need to be able to get to the side to change wire rolls. Be getting a bit high if I stack it, although it's not inconceivable. What I've decided to do is build a new trolley that will take both the TIG and the MIG, and that's what this video is going to be about. The building of a trolley for the MIG and the TIG, and I hope you follow along. This is my sketch for the trolley that I'm going to make. The key features are a rear tray to stand the gas bottles in, and 3 shelves, the top one for the MIG to stand on, the next one down the TIG will sit on, and the third, which was a bit of an afterthought, will hold the amperage control foot pedal and cable for the TIG. In the space below the bottom shelf, I will be fitting 2 drawers. They're not shown here, but these will hold respectively the MIG and TIG consumables and spares. I've not shown any dimensions on the drawing because the ones I'm using are tailored to suit my 2 welders. Also, this drawing at the time it was made was more to visualise the layout than to provide precise detail. However, if you do need to know my dimensions as a starting point for your own welder trolley build, well, hit me up in the comments below and I will tell you. I'm making this trolley to hold 2 Australian SE size welding gas bottles side by side. The SE size is slightly bigger than the standard Australian E size, holds 4.9 cubic metres or about 173 cubic feet of gas compared to the 4.1 cubic metres that the standard E size cylinder holds. The diameters of these 2 bottles, with some extra wriggle room to fit them in, will determine the minimum size of the tray. The TIG welder is the biggest and heaviest welder of the 2. It will sit on the second shelf, and its height, width and length determine the height below the top shelf and the minimum shelf size. I will add extra to ensure sufficient hand clearance to allow the TIG to be easily inserted between the 2 shelves and the trolley sides, and also some extra length so that the power lead at the back of the machine can be smoothly looped out behind. The MIG welder, having a smaller footprint, will fit easily in the shelf dimension determined by the TIG machine. The final critical dimension is to have the TIG controls at a useful height above the ground. For me, this is somewhere between my ground to wrist and ground to elbow height, bearing in mind that I will also need to see and adjust the controls on the MIG, which will be sitting above. I've not shown the caster wheels that the trolley will sit on, but have taken their height into account in calculating this dimension. Having worked out the dimensions for my application, I cut out and gathered the materials I'll use for the build. I admit that I'm a bit of a hoarder of offcuts, leftovers and recyclables, and most of this build will consist of these. Not cheap, just for your good. The main components are angle pieces for the gas bottle base, square hollow section for the base frame and sides, light angle which will hold the MIG and TIG shelves, also sheet metal for the gas bottle base and the shelves. The material for the 3rd shelf and the drawers is yet to be found at this stage. I use 50 by 50 millimeter angle iron, 6 millimeters thick, to make the simple rectangular base with mitered corners in which the gas bottles will stand. A plate will go in the bottom. I regularly check diagonal measurements to ensure it is square. With the gas bottle frame made, I then welded on 50 by 50 millimeter square hollow section to complete the base or chassis of the Welder Trolley. Again, checking the diagonals. Checking the diagonals again. Again, checking the diagonals. With the base of the trolley welded out, I move on to fitting mounting plates for the caster wheels that the trolley will run on. But first, I need to grind flat the welds where the plates will sit. The plates are 100mm square and 8mm thick and are fitted to the corners of the trolley base. Next, I inserted a piece of 3mm thick plate to form the floor of the gas bottle stand and welded it in place. The bottles are heavy, but this base is a solid construction. If the angle and plate were thinner, I would consider positioning the rear wheels under the centre line of the tray to better cope with the load. The trolley will run on 4 caster wheels, and the mounting plates were pre-drilled to fit their bolt pattern before being welded onto the chassis. Before threading, however, I'm drilling each hole through the trolley chassis to ensure the mounting bolts do not bottom out. I hand tapped each mounting hole to suit M8, which is metric size, having a diameter of 8mm and a pitch of 1.25mm. With all the mounting holes tapped, I check the fit of the casters before moving on to build the body of the trolley. With the chassis or base of the trolley done, I moved on to the sides. I'm making the hoop sides out of 40mm square hollow section. Having tack welded the mitered corners, I measured the diagonals to check that the frame is still square, always a good move. With the frame still clamped, I welded on the middle shelf support. This will also hold the hoop frame square when the clamps are removed. Notice that I fitted a spreader clamp to the inside of the hoop. Once the bottom clamps were removed to fit the shelf mount, the hoop sides flexed inwards at the bottom. The top only being tack welded together, however, allows a bit of movement, enabling the distortion to be easily corrected with the spreader clamp. The two sides are mirror images of each other, and before welding the joints fully, I stand the two sides together to make sure. With the sides welded out, I'm ready to weld them to the base. I am clamping the frames to the base with sash clamps and setting the top separation with the spreader clamp. There are a few ways of setting this up. You can do it piecemeal, welding one hoop frame on and then the other, but my preference is to set both frames in place at the same time. Small variations in cut length can lead to unwanted distortions. I need the shelf brackets to be on the same level and parallel to each other, and laying out the full frame structure is the best way to ensure this. Having tacked the frame together and checked that all was square, I then fully welded out the hoop leg to chassis joints. Before I fit the mounts for the top shelf, I ground flat the inside welds on the hoop corners. Then it was on with the top mounts for the MIG shelf. The mounts, both these and the middle shelf ones, are 600mm long lengths of 50 by 50mm steel angle, 3mm thick. I had originally cut 3mm thick by 25mm strips to run between the mounts front and back to act as spacers and to further support the actual trays. In the end, the hoops were rigid enough and the shelves strong enough, and these spacers were not needed, and I didn't use them. I next welded a length of 50mm wide, 6mm thick flat bar at the back of the frame. I'll be adding chain hooks to this bar to hold the gas bottles in place. The angle used in the gas bottle base is 6mm thick, and using this thickness of flat bar maintains the bottle upright in the trolley. I then welded both the shelves to their respective mounts. The MIG and TIG shelves are formed from 1.6mm thick steel sheet with 10mm wide bends at the unsupported ends. These act as strengthening ribs, and the front one is bent down and the back one is bent up. Despite building this trolley to hold my MIG and TIG welders, this is the only time I'm using one of them in the construction. Here I'm using flux core MIG to weld the shelf floor to the mounts. The purpose of the bottom shelf is to hold the foot pedal for the TIG and only needs to be lightly built. It's a similar layout to the other two, but the shelf floor is only 1mm thick, and because it is placed only a short distance below the TIG shelf, the shelf is being constructed as a unit before the mounts are welded in place between the hoops. The floor is a product called Zinc-Alume, which is steel sheet plated with zinc and aluminium as corrosion prevention. It can be welded, but the weld normally burns away the coating, requiring good ventilation. It seems a good use for flux core, as the flux deals with the zinc and aluminium in the Zinc-Alume sheet, the zinc in the galvanized angle mounts, and the wire makes welding the 1mm sheet to the 3mm thick angle just that little bit easier. With the bottom shelf made, I clamped it in place and welded it to the frame. Below the shelves I am fitting two drawers, and I start on them by welding C-section side pieces inside the hoop frame. These will be the mounts to which I will later fit the drawer runners. With the mounts welded in place, I move on to fit the drawer slides. The type I'm using has ball bearing runners, are rated for the weights that I'll be putting in the drawers, and provide good support when pulled out. Mounting the drawer slides on the frame is the easy bit, I think. For me, all the alignment troubles start with fitting the drawers to the slides. At this stage I'm using self-drilling screws to fix the drawer slides in place. The slides will be removed for painting and after that refixed with blind rivets. I am making the drawers out of 22 gauge or about 0.76mm thick steel. As I said in the beginning, most of this trolley is being made from leftovers and offcuts, and the fact that I can tell you the gauge size of this sheet in modern Australia tells you that I've had it for a while. The build is forming a three-sided box to which a front piece is fitted once the drawer position is established in the frame. With the basic bending done, I'm creating a rollover along the top of each of the three sides using a piece of 8mm diameter steel rod as a former. The purpose of the rollovers is to give the drawer sides more rigidity. Once the three-sided box is formed, it is on to mounting the slides. Once again, I'm using self-drilling screws to fix the slide in place. These will be replaced with blind rivets after painting. With the slides mounted and the drawers in place, I fitted the drawer fronts. The fronts are bigger than the drawers and need to be fitted so that there's an even gap between the drawers and, in the case of the top one, to the bottom shelf. With the drawers fitted, it's off to paint. Off camera, I have fitted chain hooks to the crossbar to hold the gas bottles and also side hooks to hold the cables from the two welders. Back from paint, it is time to fit the trolley out with the welders and their accessories. And then we're ready for action. Well, that's it. It's all set, ready to go, ready to do some work. All I've got to do now is cut and shunt the other one, reduce its size a little because it's only got to hold two welders and not a gas bottle anymore. This I think is going to work well for me, and I hope you found the video both useful and, if you're thinking about making your own trolley, perhaps useful in helping you decide on what you need to have, what you need to incorporate in your trolley. Thank you once again for watching, and if you haven't already subscribed, well, why not subscribe? It's easy. Just hit the subscribe bar down below. While you're there, ding the bell so that next time a video from the White Dog Garage YouTube channel airs on YouTube, you'll get a notification. Thanks again for watching, and I look forward to talking to you in another episode. Bye.